The figure below shows the behavior of emission by a radioactive isotope X. Use it to answer the questions that follow. So, study the diagram. First, you can see this radioisotope source. This one is positive. This one is negative. So we have T and we have P. So explain why isotope X emits radiations. So an isotope emits radiations because it is unstable. So it means that the X is unstable. So a radioisotope which is unstable will always will undergo radioactivity to emit radiations. So it is unstable. Name the radiation labeled T. T, it is deflected towards the negative. So if it is deflected towards the negative, then it means it is what? It is the alpha. Because we know alpha is positively charged. So positive attracted to the negative. So T is alpha particle. Arrange the radiations labeled P and T in an increasing order of ability to deflect by an electric field. Now that one, you consider this. Remember this is gamma. It means this is beta, because we have said this one is alpha. Look at the diffraction from gamma, and look at the diffraction here. The diffraction here is small, is bigger. Alpha particle is very heavy when you compare with beta. So beta diffracts more because it is lighter. So that's what they want us to do here. Arrange the radiations labeled P in increasing order of the ability to deflect. Therefore, T going to P. So P deflects more than T in increasing order. Calculate the mass and atomic number of element B formed after this element here has emitted 3 beta particles, 1 gamma ray, and 2 alpha particles. So we start with our X, atomic number 80, 212. When we go to the right, we subtract for alpha. So alpha, how many alpha? 2 alpha, so 2 alpha plus gamma plus 3 beta, or we can write it 2 alpha is 2 H, 2 helium, 2 4 plus gamma plus 3 electron negative 1 O. You can represent this one like this. So what are we doing here? We know when we go this side, the mass number is for alpha, with the mass number decreases by 4 and the atomic number decreases by 2. So let us see here. So how many we are going to decrease? 2 for alpha. We are going to decrease the mass number. So let us write mass number 212. Subtract everything here. Subtract 2 alpha. 2 times 4 plus 0 times y. We call it y or whatever. A gamma, that is. And this one is 3 times 0. That is for beta, because 0 times this. So when we subtract this, we realize this 212 subtract 8 for alpha. So the mass number is 204. Atomic is 80 minus this total. For this one is 2 times 2, which is 4, plus for y it is, for gamma it is 0 times y, which is just 0. For alpha, for beta, it is 3 times negative 1 So this is negative 3. 4 minus negative 3 is 1. So 80 minus 1 is 79. So this is the atomic number, and this is the mass number. Write a balanced nuclear equation for the decay of this to be using the information above. Now that we have the atomic number, we have the mass number, now we can complete this equation. So there was B here. So now we have X 80 to 12 forming B 79 204 plus how many alpha? 2 alpha plus 1 gamma plus 3 beta, and that is the equation. That is the equation. X grams of a radioactive isotope takes 100 days to disintegrate to 20 grams if the half-life period of the isotope is 25 days. Calculate the initial mass of X of the isotope, of the radioisotope. So we have the total time taken for it to disintegrate, but we have one half-life is 25. So that one helps us to calculate first how many half-lives are there. So number of half-lives equal to 100 days divided by 25 days. That one will give us 4 half-lives. 4 half-lives. So what is remaining is 20. So we can start there. So when we have remaining, we want to get the original, we multiply times 2 times 2 times 2, depending on the number of half-lives. Now we have 4 half-lives. 20 times 2 is 40. That is first half-life. First. Second half-life, because there are 4. 80. Third half-life, it is 160. And then fourth. Fourth is 320. So first, second, third, fourth. So it means the original mass or initial mass was 320 grams. You can also use the formula. We know that the remaining amount is equal to a half times n times original mass. Remaining is 20 equal to a half raised to power n, and n is the number of half-lives, which is 4, times original, we don't know why. So 20 equal to, this is 1 over 16 y. Multiply both sides by 16. Both sides by 16. So this is 320 equal to y. So the original is 320 grams. Radium has a half-life of 1620 years. What is a half-life? It's very important. You should know how to define a half-life. A half-life is the time taken for a radioactive isotope or a nuclide, for a radioisotope and nuclide to spontaneously decay or disintegrate to a half its original or initial mass, to disintegrate to a half. So when 320 disintegrated to form 160, that's a half. 160, 80, that one is, so here we have this, one of them is called a half-life. This is another half-life, another half-life, another half-life. So a half-life is just the time taken for For this one, it takes how many days? 25 days. Here it is 25 days, 25 days, 25 days. That is now a half-life, and I've also told you that a half-life is always a constant. 25, 25, 25. This makes 100 days. If 1 milligram of radium contains these atoms, this is 10 raised to power 18 atoms. How many atoms disintegrate during 3,240 years? But we know the half-life of radium is 1620 years. That is the half-life, but it takes 33,200 years. Now we can get the number of half-lives, which is the total 3240 years divided by 1620 years, and that one gives us 2.5 lives. So it has 2.5 lives. So 1 gram. So we are starting from 1 milligram. So 1 milligram will disintegrate to 0.5 milligram to 0.25 milligram. Why did I stop here? I stopped here because we have only 2 half-lives. First, second, 1, 2 half-lives. Right? Remember, this 1 half-life is 1620 years. 1620 years, making a total of 3,240 the whole total time taken for this amount to remain. So what the question is asking us, if 1 milligram is this, how many atoms disintegrate during this? So how many will disintegrate? Remember, this one is remaining. This one is called the remaining. Very important to understand that remaining amount. So if we want to know the amount that it is integrated, it is the total minus remaining. Very important to note. But we know that 1 milligram contains 2.68 times 10 raised to power 18 atoms. We will ask the remaining amount, or because it is asked, okay, let us get the remaining amount. The remaining amount is 0.25, so we have 0.25 milligrams will contain how many atoms? So it is 0.25 times 22.68 times 10 raised to power 18, and this one will give us 6.7 times 10 raised to power 17 atoms. Remember, I have done for 0.25 atoms remain. This is what is remaining. But the question is asking us how many atoms disintegrated, decayed. So if we had 1 and we are remaining with 0.25, it means 0.75 were disintegrated. You should know that. You can also do directly like that. So we can now get number of atoms that disintegrated, number of atoms that decayed equal to the total, which is 2.68 times 10 raised to power 18, subtract the remaining amount, 6.7 times 10 raised to power 17, and this one will give us 2.01 times 10 raised to power 18. Another way you can do it directly. You will say 1 milligram equal to 2.68 times 10 raised to power 18 atoms. If this one were used or remained, then you subtract 1 minus 0.25. You get 0.75. These are that decayed. So you say 1 milligram equal to 2.68 times 10 raised to power 18. What about 0.75? So you should get this answer. The graph below shows the mass of radioactive isotope plotted against time. So this is mass against time. Using the graph, determine the half-life of the isotope. So how long does it take for 10 grams to decay to 5? Because 5 is half. From 5 to 2.5, that is a half. So you can see how many half-lives are there. It is 5 to 5 to 2. That's the one that you can see. So you can see from the graph, 10 grams decays to 5 grams takes 8 days. Can you see that? So you can 10 to 5. So you go across and then come down. How many days are you seeing here? 8 days. So it takes, for it to decay a half to half, it takes 8 days. So let us see from 5 to 2.5. You see, it is coming to 16. So you can 16 minus 8 is 8. Therefore, half-life is a constant. So also from the graph, five grams decays to 2.5, taking 8 days. Therefore, a half-life equal to 8 days. Calculate the mass of isotope decayed after 32 days. So we have find that one half-life, it takes 8 days. But now we have up to 32 days. So we find how many half-lives are there. So number of half-lives equal to 32 days. The total divided by 8, 1 half-life. That one gives us 4 half-lives. 4 half-lives. So once we have the original from the graph, you can see the original is 10, right? The original is 10. So we can now see 10 going to 5 grams, going to 2.5 grams, going to 1.25 grams, going to 0.625 grams. Why didn't I continue? Because we have only 4 half-lives. 1, 2, 3, 4. 4 half-lives. You can see that. Therefore, you stop when the number of half-lives is finished. So if this from here is 8 days, this one is 8 days, 8. So 1, 2, 3, 4. The total should be 32 what? 32 days. You should know that. Now the question is, calculate the mass of an isotope decayed after this. So you can see the mass remaining equal to 0.625 grams after 32 days. This is what will remain. As well as you can use the formula is saying that remaining amount equal to a half raised to power n times y times original. Now we want original, we want the remaining amount, which is equal to a half times n. N is the number of half-lives, therefore, times original, which was 10, because we have original. So this is 1 over 16 times 10. This is same as 10 over 16. 10 over 16 is simply 0.625 grams. Now, most of the students will fail to get the last mark because they did not understand the question. The question asks, calculate the mass of an isotope decayed. They did not ask what is remained, right? So, if this one has remained, 0.625 has remained, and the original was 10, what was the amount that it decayed? So, it is 10 grams minus the remaining 0.625 grams. That one will give you 0.9 not 0, 9.375 grams. This is the mass that decayed. So you realize that most of them will leave the answer at 0.625, the remaining amount, yet the question was asking you to calculate the mass that decayed. So you have to get the question right. A radioactive isotope X2 decays by emitting 2 alpha particles and 1 beta to form this. Write the nuclear equation for the radioactive decay, the nuclear equation. So we are starting with our X, which you don't know. What radioactive decays by emitting. So this one is the one that is decaying, and it is giving us Bi 83 and 214. So we want to get this, which decays by emitting 2 alpha plus 1 beta. 1 beta is that just E -1 0. That's 1 beta. So we have written the equation, but now we need to know what happened. What is the mass number of this, and what is the atomic number of X2? So we know that to going this way, it is in subtracting. So if already this one has subtracted 2 and then added 1, so subtract 2 and then add 1. So it means that this one was, so when we are going this way, we add 2 times 2, 4. So add 4 here. That is 87. 87 minus this -1. So this one is 86. Helium, it is 2 times 4. Right? Now, remember when we are going this way, we subtract. But when we are going back, we add. So 214 plus 8. Right, will give us 222, but this one is 0 plus 0 minus 0 plus 0 is just useless. So the answer here is 222, and that is the atomic mass. It is going the way. What is the atomic number of X2? 86. We can see it is 86. After these days, 1/16 of the mass of X2 remained. Determine the half-life of X2. So 1/16 is remaining, so we start from 1 going to 1/2, going to 1/4, going to 1/8, going to 1/16. How many half-lives? 1, 2, 3, 4. Right? So we have 4 half-lives. 4 half-lives. But we know that it takes, the whole decay takes to 112 days. So we can say that the 4 half-lives takes 112 days. The question is asking, determine the half-life, 1 half-life. So 1 half-life equal to what? So it is 1 times 112 divided by 4, and this one gives us 28 days. So 1 half-life is 28 days. 28, 28, 28. When you add them, they should give you 112 days in total. These and these are isotopes. What does the term isotope mean? You should know that these are atoms. Isotopes are atoms of the same element with the same atomic number, but different mass number. A radioactive substance emits 3 different particles. Identify the particles with the highest mass. The highest mass is the one which is heavier, and I've told you that one is alpha. Alpha is heavier. equal an electron is better. Below is a radioactive decay series starting from Bi and ending at lead. Study it and answer the questions that follow. So we are starting at B83. We are going the way to 82 lead. Identify the particle emitted in step 1 and step 3. Step 1 and step 3. So step 1, you look at the atomic number, what is happening, and the mass number. This is 210. 210. So from 214 to 210, 4, subtract 4. 83, subtract 2, you get 81. Therefore, this one is alpha. Step 3. Step 3, the mass, the atomic number here is 82, here it is 83. Mass number remains the same. That one is beta. Because for beta, the atomic number will increase by 1. Atomic number will increase by 1. Mass number remains the same. So 1 is alpha particle, and this one is beta particle. Write the nuclear equation for the reaction takes place in step 1. Step 1, we can see very clearly this Pi, which is 214.83, and are going the alpha particle to form Ti 81 to 10. Then you add helium because it has undergone alpha decay, one of them. That is all you need to write. Step 1 to step 3. So step 1. Now write those in nuclear equations in step 1 to 3, step 3 to 4 to 5, step 1 to 5, and then compare with my answers after you have done. And then you will do them using this chart here, and then check your answer using what I have done here. If a sample of cobalt has an activity of 100 counts per minute, determine the time it would take for its activity to decrease to 6.25 if the half-life of the element is 30 years. So 30 years. It is easy because now we have the initial or original, and we have the remaining amount. So we start at 1,000, going to 500, 250, 125, and then we have 62.5. So we have the final, we have the initial. So how many half-lives? 1, 2, 3, 4. 4 are half-lives. So we have 4 half-lives, right? But we know 1 half-life takes 30 years. 30 years. So if 1 half-life takes 30 years, how long will it take? Because the question is asking, determine the time it would take for it to the activity to decrease, so the whole time. So it is 30 times 4. It will take 120 years for this mass to decrease from 1000 to 6.25 grams. 120 years. This one is for you. Check and answer this question. It is your homework. Hope you have seen it. Thank you.